Fitting of binomial distribution. First of all, we will try to find out whether the problem belongs to the binomial distribution, Poisson distribution, or normal distribution, or any other distributions basing on the characteristics of the problem which is given to us, problem or the distribution which is given to us. There will be a situation where tossing of a coin, throwing of a die, number of mistakes which have been appeared on the textbook, or number of accidents which has happened on the a busy road. What we will be given some kind of a situation, and we will be deciding based on the problem whether it belongs to the binomial or Poisson distribution. See, binomial distribution is having some characteristic that a problem can be followed. Binomial distribution is the number of trials should be always finite. That means countable set of number of trials only has to happen. Next, the trials must be independent of each other. Third one is there must be only two outcomes, either success or a failure, either a success or a failure. And the last one, the last condition is the probability of success is always denoted by a small p, where the probability of failure is denoted by small q, where q is equal to 1 minus p. That means the total probability is equal to 1 always. So that means p plus q is equal to 1. That is how we get the formula q is equal to 1 minus p. And the probability function of binomial distribution is p of x is equal to ncx into p power x into q power n minus x, where x ranges from 0 to n. Because out of n number of trials, we may get a success or we may not get a success. But success and failure always follows one with the another one. So sometimes we might not have a success, so x becomes 0. We might have only one success, that is equal to 1, because in n number of trials, if 10 coins are tossed, if I get all tails, then I say that there are 10 success with me, 100% I have a success. Let us suppose there are only 8 tails have been appeared, then we say that our number of successes is 8 and number of failures is 2. That means both are at a time only. So that is how we have the formula like p of x into q of n minus x. P, q, probability of success and probability of failure will be both at a place only. Now, the concept of fitting of binomial distribution. Fitting of binomial distribution is nothing but we will be given a particular distribution of problem. Will be given some x values and probability of occurrence of those values also will be given. That means frequency of the values or the occurrence of the values will be given to us. So we have to verify whether this is the best fit for the binomial distribution problem, or it is a best fit for the any other distribution. Likewise, we have n different types of distributions like Poisson, normal distribution, exponential, gamma distribution. We have different kind of distributions, but depending upon the situation of the problem. See, in binomial distribution, I already told you that the number of trials should be finite, the first condition. That means, let's take an example of one problem. See, x values are ranging from 0 to 4. That means the number of trials is always equal to 4 here. The first condition of binomial distribution has been satisfied. And here we can take that 0 success, 1 success, 2, 3 or 4, whatever it might be. If there is a situation given over here, based upon reading that particular situation, we can identify whether it is of binomial distribution or any other distribution. But for this problem, we will find out whether this problem is best fitted by binomial distribution or not. That means whether this problem belongs to the binomial distribution problem or not. So how do we do that? See, there are some values are given and those frequencies are also given on this graph. That means a histogram was drawn, and as well there is a distributed curve. That means positively correlated, positively skewed. The distribution is positively skewed over here. Now, whether this distribution is going to satisfy binomial distribution or not, we are going to find out by using this particular example. See, what do you mean by fitting of binomial distribution exactly? We have to verify whether this problem is closely related to the binomial distribution or any other distribution. Let us find it out. Now, how to find out this fit? Actually, there is some some formula to find out whether this is a perfect fit for binomial distribution or not. Now, what is that? See, actually, the generalized expression to find out expected. See here, the condition which, see, let me explain you something here. Now, we were given two columns. What are those two columns? We were given x value and f value is also given, and I have to find out new values. That means x values are 0, 1, 2, 3, 4. F small f values are called, these frequencies which are given in our problem are called as observed frequencies. We have to call them as observed frequencies. Now, I need to find out new values over here. I need to find out new values over here. What are those new values? Those which are called as expected frequencies. These values are called as expected frequencies. And let us find out the addition of our observed frequencies. After I found out our new frequency values, if I add them, if the total of both the columns are same, then we say that this problem is a best fit for binomial distribution, or otherwise it is not a best fit of binomial distribution problem. So how do we find out these expected frequencies? Already these observed frequencies are given to us. Let me write over here so that it will be clear for you. It is 28, 62, 46, 10 and 4. Now, I need to find out this column values. Once I find out this column values, and one more thing. See, by adding these values, what is the total we get? 28 plus 62, that means 70 plus 20, 90, 90 plus 10, 100, 100 plus 146 is 146 plus 4 is 150. That means summation F or total frequency capital N. Capital N is equal to how much here? 150. Now, again, I'll find out some more frequencies over here. New frequencies. Once I got to know these new frequencies, if I add this total of the frequencies, if I get again approximately equals to 150, approximately means either it is 149.997 or 150.001 is also fine. If the my calculated value is nearest to this 150 value, then this problem is a best fit for the binomial distribution. So to find out that, we have something which is called as the generalized expression. Since they are asking us to find out by using binomial distribution, let us use the formula of binomial distribution only. The generalized expression to find expected frequencies. That means to find out this capital F. Using binomial distribution, we have a formula which is called as capital F of x is equal capital N into P of x. Okay, where N is what? Where capital N is what? Total frequency. Capital N is total frequency. That is 150 of observed frequencies. And what is P of x? P of x is nothing but the probability function of binomial distribution. That is NCx into P power x into Q power N minus x, where x is ranging from 0 to N. Now, let us substitute the values in this formula and let's find out new frequencies so that we shall verify whether the total is equal to 150 or not. If that is satisfied, we are done with that fitting of binomial distribution. For that, okay, let us substitute the values over here in this formula. Now, let me consider these values. Now, f of x is equal ncx into p power x into q power n minus x. Now, that is equal to, what do you mean by n here? I just now told you that it is total frequency. Total frequency means addition of frequency values, that is 150. And what do you mean by small n? Number of observations, actually. Number of observations. How many number of observations are there? 5 observations are there. 0, 1, 2, 3, 4. Actually, 5 observations. But in binomial distribution, this highest value is called as small n, because we can have maximum number of successes are how many? 4 only, right? If there is 4 events are occurring simultaneously, I can get maximum number of successes is also 4, but not 5. If I take n value is equal to 5, can I get 5 successes at a time? No, because the event is only up to 4, right? So here the n value is up to 4. That means 2 comma 3 comma 4, x is equal to, x can take the values from 0 to 4. Why? Because in binomial distribution n value is equal to 4. Now, and then here also this n becomes 4 minus x. Now, what are the other two values I need to find out here? P and Q values. Once I know the value of P, immediately Q is equal to 1 minus P. So then, if I substitute x is equal to 0, I'll get the answer x is equal to 1, 2, 3, 4. I'll get all the answers of our expected frequency simply. So now I have to find out the value of P. How can I find out the value of P? See, if in the given distribution or if in the given question, we were given that whether it is a tossing of a coin, for example. Tossing of a coin means what? Either it can have a getting a tail or a head. That means probability of success or failure. Directly I can take the value as 1 by 2. But here it was not mentioned. So how do I get that value? Here in binomial distribution, I have something which see to, but I can find out that value from the given distribution of values. From this given distribution of values, let us see how we can do that. I'll just tell you. Let me. Now see here in binomial distribution, what is the formula of mean? What is the formula of mean? Mean is equal. Mean is equal small n into p. Mean is equal small n into p. That means here, what is the value of n that is given? See, np means n is nothing but 4 and p. That means from here, from this point, if I wanted to know the value of p, then p is equal to what happens if I take 4 to that hand side? Mean divided by 4. If I do mean divided by 4, I get the value of p. So, but where do I get the mean value? Where do I get the mean value? Very simple. See, if x values and f values are given, it is an ungrouped data where I can use the formula of mean, that is x bar is equal summation f into x by summation f. By using this formula, I can find out the value of mean from the given distribution. So where capital N is equal to directly 150, which is given. Now, what is the other thing I need to find out mean? Here f into x. See, x into f, that means 0 into 28 is 0, 62 into 1 is 62, next 46 into 2 is, it is 92, next 10 3s are 30 and 4 4s are 16. Okay, 4 4s are 16. Now, just a minute. Now by adding these values, that means summation. By adding these values, okay, not to waste the time, directly I'll write summation f into x. What is the answer? Once we add these values, we get 200 as the 200. Answer. Okay, so summation f into x is equal to 200. Now, what is the formula to find out mean here? That is x bar is equal to summation fx by n. That is equal here. Mean is equal to summation f into x by capital N. That is equal to 200 divided by 150. That is equal. Let us get the small fraction. Okay. So 53 is 54. So it is 4 divided by 3. Our main answer is 4 by 3. But we have a formula which is called as mean is equal to what? Mean is equal to NP. Just now I just told you that. That means NP is equal to how much? It is 4 by 3. That implies 4P is equal to 4 by 3. Now what happens here? 4 and 4 gets cancelled, right? Left hand side and the right hand side, 4 and 4 gets cancelled. So I'll just highlight these values for your understanding. 4 and 4 gets cancelled. So then immediately we get the value P is equal to how much? It is 1 by 3. Once I got to know the value of P, then immediately Q is equal to 1 minus 1 by 3. That means we get the answer as 2 by 3. So what is the answer of PQ now? It is 1 by 3 and 2 by 3. So once I substitute these values over here, then what does this expression becomes, man? By substituting these values onto the generalized function, then now what is the P value here? P value is 1 by 3.
1 by 3.
And Q value is 2 by 3. Okay. Now, what is f of x is equal to here? F of x is equal to 150 into 4cx into 1 by 3 to the power of x into 2 by 3 to the power of 4 minus x, where x is ranging from 0 to 4. Now, what do I need to find out? Why I'm doing all these things now? Just to find out our new frequencies, expected frequencies. What is this value? This is what small f of 0 is equal to answer is how much? 28. Small f of 1 is equal to answer is 62. Small f of 2 is equal to 46. F of 3 is equal to 10. F of 4 is equal to 4. Now, see, this we can write as, for your understanding, f of x, small f of x. And this is capital F of x. What do you mean by x here? X is equal to 0, 1, 2, 3, 4. When x is equal to 0, what is f of x value? 28. Now I'm going to find out capital F of x. That means what? I need to substitute x value equal to 0. Then I'll get the value over here. Where do I need to substitute my value? In this expression. Why? Because capital F, right? Now, let x is equal to 0. Then what happens? Capital X, right? It is f of 0 is equal, then what happens? Simply wherever we have x, we are going to write the value as 0 now. We are going to write the value as 0. Then what happens? That is equal 150 into 4. 4 is 0 means 1 into 1 by 3 to the power of 0. Something power 0 is nothing but 1 into, see, 4 minus 0 means 4. That means 2 by 2 to the power of 4. That means 2 power 4 means how much? 2 power 4 means 2, 4, 8, 16. So 2 power 4 is nothing but 16 divided by 3 power 4. 3, 9, 27, 81. So 16 divided by 81. So now once we do this calculation part, we get the answer as 29.63. 150 into 16 divided by 81, we get the answer as 29.63. Whenever we get a calculated answer in decimals, let it be 2 points or 4 points. After the decimal, let it continue up to 4 points. No problem. Now, next one. So I got what is capital F of 0 value here? It is 29.63. 29.63. I got one first value. Now let us find out the second value. Then what is that? I'll just copy this one so that it will be very easier for our calculation part. So now let x is equal to 1. Then f of 1 is equal 150 into 4c1 into 1 by 3 to the power of 1 into 2 by 3 to the power of 4 minus 1. So then 150 into 4c1 is nothing but 4, and 1 by 3 to the power of 1 means it becomes 1 by 3 into, now it is 4 minus 1 means 3, 2 cube by 3 cube, 2 cube means it is 8 and 3 cube is 27. So now by doing the calculation of this particular expression, we get the answer as 59.25. Okay, 25 or 26. Now next, similarly, let us substitute the value of x is equal to 2. Sir, how many numbers we have to be continue? See, we were given x values ranging from 0 to 4, so we do the calculation also up to fourth value only. So next, 4c2 1 by 3 to the power of 2 into 2 by 3 to the power of 4 minus 2. Then what does it become? 150 is always 150. Now 4c2 in combinations, 4c2 value is 6. Now next, 1 by 3 to the power of 2 means it becomes 1 by 9. Now 2 by 3 to the power of 4 minus 2 means it is 2. That means 2 square is 4 divided by 3 square is 9. 4 by 9. So then our answer will become 44.44. 44.44. Now next, let x is equal to 3. Let x is equal to 3. Then f of 3 is equal 4c3 into 1 by 3 to the power of 3 into 2 by 3 to the power of 4 minus 3. Then we get 150 into 4c3 is nothing but again it is 4. 1 by 3 to the power of 3 means 1 by 27, and 2 by 3 to the power of 4 minus 3 means it is 1, right? So we get only 2 by 3. So by doing this calculation, see, all the time in all the expressions our denominator is 81 only. Okay, now by calculating this value we'll get 14.82. 14.82. Now next value, the last value, what we are going to find it out is let x is equal to 4 now. Then f of 4 is equal to 4c4 into 1 by 3 to the power of 4 into 2 by 3 to the power of 4 minus 4. So 150 remains as usual. 4c4 is nothing but 1. Next, 1 by 3 to the power of 4 is nothing but 1 by 81, and 2 by 3 to the power of 0, right? So it is 1. So then our final answer is 1.85. So the answer is 1.85. Now let us go for the tabulation of these values. Let us tabulate these values now. That means let us substitute in our actual table. Let me copy down this one. Let us substitute here. Now let us verify whether this has been fitted or not. See, now what is f of 1 value? It is 59.25. Next, f of 2 value is 44.44. Next, f of 3 value is 14.82. Next one, last one is 1.85. So by adding all these values, we get the answer as 149.997. 149.997. That means this value is approximately equals to 150. So observed frequencies total and expected frequencies total is same. If that totals are same, hence the binomial distribution has been fitted. If not, the binomial, this means this problem is not a best fit for binomial distribution. So that is how we find out the answer. See, what did we do here? We were given a problem and they asked us to fit a binomial distribution for this problem. That means whether this problem is a best fit for binomial distribution or not. So to find out this expected frequencies and to get the total as 150, that means we are trying to find out whether it is 150 or not. We have taken a generalized expression. What is the formula of capital F of X? It is capital N into P of X. So now what is n here? Total is 150. That means we are trying to find out whether this 150 is correct or not. So that is why we are using that 150 in our formula, that is equal to n into, they are asking us to verify it with binomial distribution. So into P of X. So now from the given table, I came to know that total is 150 total frequency and the number of trials are 4. And next I need to find out the values of P and Q so that I can substitute X value equal to 0, 1, 2, 3, 4. I'll get the answers. So from the given distribution, I had an idea that I can find out the value of P by using mean of the given distribution, because I have only one chance to find out P is I need to get mean value. So once I got to know the mean value, mean divided by 4 is equal to P. Why? Because n equal to 4 here. So immediately I found out mean of the ungrouped data. There I got the answer as P equal to 1 by 3. Immediately substituting in Q formula, I got Q is equal to 2 by 3. Now let us substitute those values onto our problem, that is function capital F of X is, I got this expression. From there, now simply substituting, why we are substituting 0 to only, sir? Because X is always starting from 0 and it will end up at number of highest successes. So I've substituted X is equal to 0, 1, 2, 3 and 4. Finally, I have got some calculated answers. That means these are the expected frequencies values. I have substituted in the column and I got the answer as 149.997. So approximate value is equal to 150. Therefore, observed frequency value and the expected total frequency value is same. Hence, the problem is a best fit of binomial distribution. That is the conclusion of the problem.